y'all, welcome to Miss Clark's chemistry class. This is the third lesson in a series of lessons about oxidation and reduction reactions. This lesson, we're going to talk about how to balance these in a neutral solution, how to balance an acidic solution and a basic solution. We're just used to balancing normal reactions, and it doesn't matter what kind of solution they're in. But for a redox reaction, it does matter. We're going to have to go through just a couple more steps than what we're used to. So go get your notes, go get something to write with, and let's get started. Since redox reactions show movement of electrons, they balance a little bit differently. So let's just jump right in. There's going to be an extra step. Okay, so to balance it, the first thing we're going to need to do is break it into its half reactions. And so let's do that. So we see that zinc is going to break into the ion zinc. And we see that copper, the ion copper is going to... Okay, so let's put those electrons. Zinc went from 0 to +2. That means that it lost 2 electrons. So let's make sure and show that. And then copper, for it to go from the ion copper to its free element copper, it had to gain an electron. So we need to show that gain. Remember, we show loss as a product, we show gain as a reactant. Okay, so here's our half reactions. Step 1 done. We need to balance for amount. This is what you know how to do. This is adding those mole ratios, those numbers in front, those coefficients. Okay, so if I'm looking, I only have 1 zinc, 1 zinc. The amount is the same. Here I've got 1 copper, 1 copper. The amount is the same. For in this example, because I'm trying to use a really simplistic example, there is nothing to balance for amount. So we're going to move on. And now we're going to balance for charge. And if we see in this first half reaction, zinc, there's 2 electrons, but in this other half reaction for copper, we only have 1 electron. We do have to balance these. I'm going to use multipliers to make sure that balances. Now in this example, we only need 1 multiplier, because if we multiply this whole thing right here by 2, that's going to get us 2 electrons, and we want our electrons to cancel out. If I have 2 electrons on the product side, 2 electrons on the reactant side, I can cancel those out. Sometimes you might have to use a multiplier to the top and the bottom if those numbers don't work out as easily as these did. Okay, so as we were talking, I went ahead and balanced for charge. Copper only had 1 electron. We needed it to balance with these 2, so we multiplied this whole reaction. Just like in math, what you do to one thing, you got to do to the whole thing. So we multiplied this whole half reaction by the 2. So I got 2 electrons, 2 copper ions, 2 copper elements. Now the only thing left is to put it all back together. So our electrons canceled out, so we don't have those any longer. Now we can just put this back together. So I've got zinc plus 2 copper ions. So we're just going to put it back together, and it doesn't have to be in the same order that I did. The coppers and the zincs can be in different orders. Zinc didn't have to go in place 1 and copper didn't have to go in place 2. Okay? Let's try another example. It is easy just to jump in and do the half reactions like I did in the last example, but let's go ahead and start from the very beginning just so we're in good practices. Okay, so let's look at this first carbon. Carbon is kind of wishy-washy. We're not sure of it, so let's skip and look at oxygen. We know that oxygen is a -2. Let's notice this. Make sure we notice that -2 charge. Okay, so we've got -8 because we have 4 oxygens, but we want the whole thing to equal a -2. Whatever carbon is going to be, it's multiplied by 2. So what must be in that square? I'm seeing a 3. 3 times 2 is a +6 and a -8. That gives us a -2. Okay, so that means carbon was a +3. Iron is already a +3. It tells us so. Let's go to the carbon dioxide again. Oxygen is a 2. We have 2 of those. That's like a -4. So this carbon is going to be a +4, right? Because it's got to equal 0. And then this iron is already telling us it's a +2. So our oxygens, they're not really a part of this. Carbon, let's make us a little note. Carbon went from a +3 to a +4. Iron went from a +3 to a +2. Okay, so let's make sure we know what's happening here. To go from a +3 to a +4, our number is getting bigger, more positive, meaning less negative. So we've lost 1 electron. And then if we look at iron, our number is getting smaller, more negative because it's gaining, and it only gained 1. So when we write our half reactions, our oxidized half reaction is going to be with carbon. Let's do that one first. And then, so let's just label that oxidized half reaction. And then our reduction half reaction, that's going to be our iron. Let's not forget our electrons. And our oxidize, let's label that reduction half reaction. So in our oxidize half reaction, we lost an electron. So we're going to put 1 electron here. And in our reduction half reaction, we gained an electron, so 1 electron here. Now we're ready to balance for amount. I'm going to get us a little bit of space. So if we balance for amount, and I'm looking at this first reaction, our oxidation, I've got 2 carbons here, but I only have 1 carbon here. So I'm going to put a 2 here. And when I did that, that gave us 2 times 2. That gave us 4 oxygens. I already had 4 oxygens. When we added that 2 here, that also is going to mess with our electron count. When we had this oxalate ion, and after we balance it, we realized that gives us 2 carbon dioxides. And if each time we break into a carbon dioxide, that gives us 1 electron. Well, if we have 2 carbon dioxides, that's going to change this number as well. So we're going to have 2 electrons here. Does that make sense? When we change the amount, that also changes the amount of electrons. If for every 1 carbon dioxide, we got 1 loss of electrons, if we have 2 carbon dioxides, then each one is going to lose an electron. So we're going to lose 2 electrons. Okay? Don't let that mess you up. Now let's look at our second one to make sure it's balanced for amount. We've got 1 iron, already balanced for amount. The next thing we need to do, now balance for charges. Our top reaction has 2 electrons. Our bottom reaction only has 1. So we need to multiply this whole thing by 2. So we'll have 2 electrons, 2 iron plus 3s, and 2 iron plus 2s. That will allow us to cancel out these electrons. Now let's put this back together. Okay, I gave us a little bit of room. So that means we're going to have C2O4 with a -2, reacting with 2 iron ions with a +3 charge, reacting with 2 carbon dioxides, and 2 + 2 irons. We're just going to put all that back together. Don't be afraid to start a new line. Don't let your work get all jumbled up. Make sure and keep it separated. I still have a few more lessons for redox reactions, so stay tuned for video number 4. Until next time, bye y'all.